Let's now talk about a second application using a stack. And the application is actually very practical. Actually, you just use it without actually ever noticing that. For example, if in your Eclipse compiler, part of its routine is really about matching delimiters, especially you're writing your block of Java code with the matching brackets, something like that. Let's take a look at the problem itself. So the problem is we would define open delimiters, either opening round parentheses, opening square brackets, or opening curly brace. And we got the matching closing delimiter as well. So this will be closing round parentheses, matching this one here. Also closing square brackets, matching this one here. And also closing curly brace, matching this one over here, right? So you want to make sure whatever expressions you write as a string of characters should really have the opening one having the corresponding closing one. That'll be the informal description. Let's take a look at two examples. This one will be considered as correct. It will be considered as matching. You can see these two are matching, this pair. What about this one over here? This one is nested, but also matching, because you can see we start with two opening ones, and we end with two closing ones. So you can think about this inner closing parenthesis is matching this inner opening round parenthesis as well. And this outer parenthesis is also matching this outer parenthesis. That's kind of the principle. And you can also apply the same reasoning. This expression over here is also matching, because you can see all the opening one you got up to, until here. We got 1, 2, 3, 4. We got 4 opening ones. And also we got 4 closing ones over here. And the closing one, you can see this one is really matching this one. This one is really matching this one. And this one is matching this one. Finally, this one is matching this one. So this is a very perfect example of matching cases, matching delimiters. Let's see some example where we don't really have matching delimiters. We got at least one that's not actually matching. What about this one here? Can you see what's wrong over here? Well, you can see up to here we got the opening ones over here, right? This one over here is matching this one. Awesome. This one is not actually matching this one. Oops. So now actually we don't really have the matching one, right? So the order of matching the opening delimiters is actually very important. And so that's about the problem itself. And if you're now looking at the slides, I would suggest close your slides, because I would really like you to really think about how you can sketch out a solution and then think about the how to write a Java code. So what I will do is I'm going to let you pause the video right now and try to see if you can sketch out a solution. You don't really you can feel free to write a Java code if you like, but on a piece of paper sketch out the solution to see how you can. I can tell you the hints. The hint is use a stack. It's a very natural it's a very typical application that can naturally use a stack to really solve the problem quite easily. Right, you can now pause the video and think about it. Alrighty, so hopefully you got a chance to give it a try. And so this will be the sketch of solution, and I would suggest you can definitely read it yourself. But let me go directly to the Java code, and I'll run maybe 4 different test cases together with you just to make sure you understand how the code works. But I would suggest if you really understand how it works, just try to maybe redo it by yourself without looking at the solution. That'll be maybe the best way to really test if you really understand the exact details. Right, let's now talk about it. And so this method here is called isMatched. It returns a boolean. If the expression has matching delimiters, it will return false otherwise. The input is simply a string of expression. So what we'll do is we're going to consider the expression as an array of characters, and we're going to use some methods from the string class, the very basic ones, nothing fancy. Okay, and it'll be most important for you to really understand about these two constants over here. One is called opening, the other one is called closing. You can see the opening one actually got parentheses followed by square brackets followed by the curly brace, and the closing one actually has arranged its order in a particular way, right? You can see here we got the matching round parentheses matching this one here, right? And also we got a square brackets matching this one over here, and also we got the curly brace matching this one over here. So let me be more precise over here. If you look at the corresponding indices of the string, you really got a matching opening and also closing delimiters. That's really the heart to this algorithm over here. All right, let me just write it down over here. So you can think about, we got the opening, and also we got the closing, right? Let me just use different color. And also closing. And for the opening, we actually got this, followed by this, followed by this. And for closing, we got this, followed by this, followed by this. And if you think about the indices for the string, this will be index 0, index 1, and index 2. So if you try to look at index 0 for the two strings, you got a matching delimiters. If you look at index 1, you got matching delimiters. If you go to index 2, you will actually get a matching delimiters as well. And this insight is actually very important to understand how the algorithm work. All right, and then we actually got the next line. We got openings over here, which will be a stack. And the stack will just be storing character. You can see now we are instantiating the element type in the stack as a character, single character. And we got some loop counter over here. We got some Boolean flag as well, right? Found error. Initially, we haven't found any error. As soon as we have found any error, we can exit from the loop. So if you look at a while loop over here, we're saying that we're going to keep iterating the input string as long as we have not found an error. And also the index that we are looking at in the input string is actually valid, right? So what does it really mean when we exit from the loop? So that's always some natural reaction, reflective action you should really have whenever you see some logical operation for the state condition for the while loop. So this one over here simply means you exit from the loop if either the found error is actually true, or, right, remember De Morgan, which we spoke about earlier, or the I is no longer a valid index anymore for the input string, for the opening or closing, for the input string, for the expression larger than or equal to the expression dot length. Right, so that's a very important insight to also keep in mind. Okay, exit. Right, let's now talk about in each iteration what should we do, right? You can see here, let's see this. We simply just get the current character by using character at I, right? So we're going to go over the input string character by character. In this case over here, if opening, which is this string over here, the index of the current character we're looking at is not equal to -1. That means the input character we are looking at is an opening character. In that case, we simply just push. All right. So this one over here, let me just annotate very quickly just to show to you. So this condition over here tells you the current character is an opening character. So this condition over here tells you that C is an opening character. Right? What about the else part? The else if part. The else if part tells you the opposite. To say that you can see the same character C, index of closing. That should not be and that's not -1. So that means the character C is a closing character. So either C is opening or closing. Either one of the opening characters or one of the closing character. And by the way, we make the assumption that you don't actually contain. Actually, I think the algorithm will still work if you actually just include any characters other than these 6. But let's make the assumption that we simply don't have that, just to simplify the scenario. Okay. And so this part over here tells you that the C is actually closing. All right. And let's now talk about the remaining part, right? You can see under the circumstance where it's a closing character. So this is where the matching should really start, right? So whenever you only got an opening character, you don't really do any matching. You only just push onto the stack. But if you got any closing character, this is the timing where you should really start matching the existing opening character that have been pushed onto the stack so far. All right. So we got 3 cases over here. Case number 1, case number 2, and also case number 3. Let's talk about each case individually. And let me focus on case number 2 over here. So this is the matching case, meaning that we have matched the current closing character with the last inserted or last pushed opening character. That's really what it means. But let's take a look at the code itself. It could be a little bit confusing when you first look at it. So this is the condition for the second case over here, right? You can see we are doing some relational comparison between the closing the index of C. So the character C is what we are looking at, and closing the index of to see which closing character it is. For example, the closing character index could be, let's say, index 2. In that case, if this is the case, what should be the corresponding matching opening character that's on top of the stack? It should be index 2 over here, right? So that's why this is exactly what's happening over here. So you want to go to the opening stack, look at its top, and see which opening character it is. In that case, if it is matching, for example, if the index for the closing character is 2, in that case, the opening character that's on top of the stack, its index should be 2 as well. If it happens to be, let's say, 2 and 1, then in that case, they are not matching, right? So that's really the essence for this second case. And if it's really matching, that means we have matched the top of the stack for the closing character. In that case, we can simply pop it off. We can now wait for the next matching to begin. Right? Let's see the other two cases. The other two cases is where we should really set the Boolean flag found error to be true, meaning that we have found some error, but they are errors of different nature. Let's take a look. The first one over here, let's see over here. The first one will be opening star is empty over here. Okay, this one over here. Right. So this one over here, let's see what's going on over here. If you look at this one here, if we have some closing character over here to be matched, for example, if it is this one over here. However, we simply have no opening character in the stack. In that case, they are really not matching. So what's happening over here is we got more closing characters than the opening characters. One of the test cases will go like that. Okay, so this means we got more closing than opening. Right, so that's this error case over here. Right, what about the third case over here? The third case over here, just the else part for this if, meaning that the closing character and the opening character, they simply don't match, right? That's a slightly simpler error case to really understand. All right, so let's now annotate it. So what I mean to do is I'm going to use the blue over here. Eventually, when I trace the different inputs, you'll see that we got matching colors for each one of them. So that's why I'm being very careful over here. Right, so the else part over here simply means it doesn't really indicate whether we got more closing characters than opening characters. Well, we don't really have more opening characters than closing characters. It doesn't say anything like that. It's just saying that for the closing character and the opening character on the stack top, they simply don't match. Closing not matching opening. So far, we got one matching case. We got two different error cases, right? Oh, sorry. One matching case and two error cases. And we got one more error case, okay? And let's say we execute this loop for as many iterations it might take. But notice that as soon as the found error is set to be true, that means we have found at least the first mismatching case. In that case, we're going to exit from the loop, as we explained before. Finally, when we return, notice what we are returning over here. We want to return a conjunction of two conditions. Number one is no error has been found, which means it's neither this case nor this case. But we got one more condition over here, right? So we want to make sure the openings stack is actually empty in order for the entire expression to be matching. If somehow we got more opening characters than closing character, in that case, after we have matched all the closing characters, we still have some remaining opening characters yet to be matched, but we already reached the end of the string. But the conclusion is, in that case, it will still be considered as an erroneous case of not matching. Right? Let me write it down. Right? Hopefully, so far, it's very clear to you about the three different error cases. Over here, so this one over here is the final error case that we have to worry about. Okay, this one here is about more opening then closing. Right? You can definitely compare this case over here with this case over here, right? They're kind of symmetric to each other, but they're both erroneous cases. Right, so that's about the algorithm, and let's now go over 4 test cases which will exemplify each one of them. Right, let's now take a look. Now that you understand the algorithm very well, so we can walk through the test cases very quickly, but I would suggest you actually set a breakpoint for each one of them and try to step into the is matched algorithm, the method, to see how exactly algorithm will be executed. Let's start with a very simple one. What if the input is simply a string? In the case of the string, you just cannot find any violation of the matching. In that case, it should be considered as matching, right? Is that the case? If we simply got input string being empty, I initialized to be 0, and then I strictly less than the expression the length, which will be 0. 0 less than 0 will be false, which will make the conjunction false. So we don't even execute this loop over here. So that means we're going to get just this part over here, which will be just true. So input string will be considered as matching. That's something I would like to start with. The second case I want to talk about is this one over here, right? Take a look. This one over here. Right, so for this one here, what's going to happen is we're going to have this. How many? What? 1, 2, 3, 4, 5, 6, 7, 8. We got 8 different characters. So that means we need 8 different iterations to really decide we actually got a matching case. Right? Let's go one by one. Okay, I think, okay, hopefully that's still visible to you, right? I'm not really going to trace line by line, already walk you through the reasoning about the algorithm line by line, but let's now take a look at how it works. So for the first character is opening, so we're gonna push opening character in it, and also the second one is also opening. The third one is actually closing, right? For the closing one, we're going to check its index. The index of the closing square brackets is actually index 1. What about the index of the top of the stack? In that case, it's opening square brackets, which is also index 1. So they are matching, right? That's exactly how this line will actually work. Exactly this line over here, right? Right? Hopefully you're still following. So that means it is matching, so we can pop it off. And we're going to go to the next character, which will be closing curly brackets, curly brace. In that case, its index will be index 2, right? This will be index 2. What's the top of the stack, which will be opening curly brace, its index is also 2 over here, so they are matching. So we can pop it off, right? You can see we're gonna pop it off over here, right? So far we got matching expression, right? And we also going to continue with round parentheses and also opening curly brackets, right? Round parentheses and also opening curly brace over here. And the remaining 2 characters will be closing brace over here. If I say closing brace, its index is 2, which is matching the top of the stack index over here, which is also index 2. So that can be pop off. The final character I will see is the closing parentheses. So closing parentheses, you can see is index 0. The top of the stack is actually over here index 0 as well, right? So they are matching. So I can pop it off. So these will be the 4 iterations of the loop I need to run. At the end of the loop, once I exit from the loop, I'm going to return over here, right? Have I found any error? I have not found any error. So this found error over here remain to be false, right? It is never set true. And also, is the openings stack empty? Indeed, you can see I have popped off all the opening characters already. So this is a matching case, right? Let's now take a look at the other 3 erroneous cases. Let's see the first one over here. Let's see the first one. This one here, right? So we got opening curly brace and opening square brackets. Opening curly brace and also opening square brackets over here, right? So the first closing one we are seeing is this. It's a closing square brackets. So closing square brackets is index 1. And what's the top of the stack? It's opening 1. Its index is also 1. So we are matching. So we are still executing this particular part over here, right? However, the next character over here is the closing parenthesis. Closing parenthesis, you can see its index is actually 0, over here. But at the top of the stack, we got opening curly brace, which is of index 2. So this is index 2 over here. Sorry. This is index 2, and this one over here is index 0. So they are not really matching, right? So that's why at this point, we're actually going to execute this particular part to set the error to be true. Let me just make a final notes for you, because 2 equals 0 is actually not 2 equals 0 is actually not matching. Right? I just make a note over here. Right? So that's about the second case. That's erroneous. What about the third case over here? The third case over here, again, we got curly brace, opening square brackets. Curly brace, opening square brackets. I'll go a little bit faster. You can see this part is really matching, right? The closing square brackets. We're gonna pop it off as before. And the next one is a closing curly brace, which also matches this one here on the top, so we can pop it off. So far, so good. However, we got one more input characters over here, one more, which is opening parentheses. But at this point, the opening stack is already empty, right? You can see all the previous two characters have been popped off. So what we are facing now is we actually got 1, 2 opening characters, but we got 1, 2, 3 closing characters, right? So that's why it's not matching. So that's exactly this case over here, right? You can see the orange over here and the orange over here. And the previous one, the blue here, and also the blue here, right? The final case to see. The final case will be this string over here, right? Let's take a look. So we got opening round parenthesis, and we got opening curly brace, and we also got opening square brackets, right? So this, let me just go a little bit, zoom in. So this is the next input character, closing square brackets. It is matching this one, so we can pop it off. And then we got closing curly brace, which is matching this one over here, so it can be popped off, right? And now we have reached the end of the input characters, so we should really exit from the loop. However, you can see when we have exhausted the input string, we still got one more opening character in the stack. That's also considered as erroneous. So that's why when we try to return over here, what's gonna happen is, it's very important to see, found error over here. Error has been false, right? So we have not found any error. So not false. So this part over here will just be true. However, is the opening stack empty? No, it is not empty. So in total, overall, we're still going to return true and also not empty. So that'll be false. So this will still be considered as not matching. Right, so now we have considered all the 4 scenarios, one matching and the other 3 not matching. Make sure you understand both the code over here and also how we use the stack to really manipulate the matching process. It's a very practical application which you have been using daily in your programming endeavor without actually noticing it. Right, if you go back to the stack, that's exactly the code I just went over. You can definitely take a look at line by line yourself and look at the test cases which we just went over. I will highly encourage you to really use the debugger on Eclipse to really go line by line for each of the cases to see how the reverse, how the is matched method will actually work differently.